Okay, let's take a look at number 2 in section 8.2. We're going to calculate the arc length of this function, this curve, over the interval from 1 to 7e. Interesting range of values there. Fairly complicated looking function. It's got a quadratic polynomial term and a logarithmic function. So what's going on here? Well, remember the formula for arc length. We derived this in class. The arc length is the integral, in this case, from 1 to 7e, that's the values of a and b, of the square root of 1 plus the derivative squared. So we want to find the derivative of this function first, and then we can see what the integral will be. If I take the derivative of 1/4 x squared, that's pretty easy. Bring the 2 down. I get 2/4 or 1/2 x to the first by the power rule. And the derivative of natural log of x is just 1 over x. So I get 1 over 1/2 times 1x, 1 over x rather. So simplifying that, I get to this. Now, I do want to square that. So I want to look at 1/2 x minus 1 over 2x quantity squared. Okay, now we can expand that out and multiply it. I just want you to recall in general, right? Because this is like a, which is 1/2 x, and b is 1 divided by 2x. So a minus b quantity squared, if we FOIL that out, a minus b times a minus b, I get a squared. Inner and outer is minus 2ab plus last b squared. And also a plus b squared, what's the only difference? Well, the only difference would be the inner and outer are both positive, so we just have a plus here instead of a minus. So remember these two forms, because that's important. The goal in here is to basically simplify what's under the radical such that it is a perfect square. And then when we apply the square root, we clear out the expression and we can integrate it. Okay, so let's take a look at 1 plus the derivative squared. Here's the derivative squared. 1 plus the derivative squared is therefore 1 plus what? I'm just going to use this formula. A is 1/2 x and b is 1 divided by 2x. So it's a squared, so that's 1/2 x squared. That is 1/4 x cubed, and you can write that out if you want to. And then it's minus 2. A again was 1/2 x. B was 1 divided by 2x plus b squared. And again, you can write this. This is going to be 1 over what? 4x squared. And then, but notice when you multiply this together, you can see it's going to be, well, it's negative, but it's going to be negative 1/2. Notice 2 times a half is 1. I get x times 1 over 2x. The x's cancel. I'm just left with 1 over 2, 1/2. All right, so this 2ab is equal to 1/2. Now, 1 minus 1/2 is positive 1/2. But positive 1/2 is the same as 2ab, where a is 1/2 x and b is 1 divided by 2x. And so notice I went from this expression here to this expression, right? This is now, and again, this is 1/4 x squared. I've just rewritten as 1/2 x quantity squared. So this is a. So the 1/2 x squared is the a, and the 1 over 2x is the b, right? And this right here, 1/2 is equal to 2ab. So this is a squared plus 2ab plus b squared. So that factors back as a plus b quantity squared. Okay. And so that's how we're able to do this. Now, this is 1 plus the derivative squared. It's this quantity squared, and then I take the square root. So what happens is I just get 1/2 x plus 1 over 2x. And I just rewrote 1 divided by 2x this way in anticipation of integrating. Okay, so now I can find the antiderivative. What's the antiderivative of 1/2 x? Well, it's 1/2 times what? X squared over 2. 1/2 times 1/2 is 1/4 x squared. And then here, the antiderivative is what? 1/2, antiderivative 1 over x, natural log of x. Okay, limits of integration, I plug in 7e. So I get 7e squared here, the natural log of 7e. All right, there's the evaluation at 70. And then plug in 1, I get 1/4 times 1. So that's minus, got 1/4 plus the natural log of absolute value of 1 is 1. Natural log of 1, though, is 0. So when I plug in 1, I just get 1/4. So it's minus that 1/4. And they wanted, I think in this case, a decimal approximation, um, or I'm not sure. Actually, I didn't write down exactly. I can't remember. But here's the exact answer. I mean, you could square 7 here, so you get 49 fourths e squared, I guess. I could use a property of logarithms to write this as the natural log of 7 plus the natural log of e, which is natural log of 7 plus 1. So I could do some more simplifying, I guess. Um, again, if you get to this point for me, I'm happy. Of course, you can approximate it, and that's a good idea if you're looking at this function graphically, and you can see, is this a reasonable value for the length of this curve over the given interval? Okay, so a little tricky here. There's not too many functions that we can easily do with this arc length integral because of this radical. But if we can simplify under here and get a perfect square, which turns out we can in this particular function, then it's much easier to evaluate it. Okay, hope this helps.